When a conductor moves through a magnetic field, a potential difference is induced across the conductor. So here the word induced simply means to be created by something. The simplest way of demonstrating this is by waving a conductor between two magnetic poles. Remember that there will be a magnetic field between these, which we can represent with field lines. This tells us that magnetic materials will experience a force in this region. But these field lines are important for another reason. If we move this conductor down between the magnets, it will cut across the field lines. You don't need to know why at GCSE, but this results in there being a potential difference between the ends of the conductor. Remember that we can abbreviate potential difference as PD, and this potential difference would allow a current to flow if this conductor was part of a circuit. But is this potential difference permanent? Well, the induced potential difference only lasts as long as the conductor is moving. So when we waved the conductor through the field, the potential difference would have only lasted for as long as the conductor was moving, which would have only been a brief moment. But if instead we keep waving the conductor and move it up and down like so, then it keeps moving in the field, so the potential difference won't go away. Technically, this would result in a constantly alternating potential difference, but we'll learn more about that elsewhere. But is waving the conductor like this the only way of inducing a potential difference? A potential difference can also be induced by a magnetic field moving around a conductor. So this time, let's hold the conductor still and move the poles up and down instead. By doing so, we're also moving the field. And as we do so, the field lines will cut through the conductor, meaning that there will be a potential difference induced between its ends. It doesn't matter which of the two moves, just so long as they're not both still or not both moving in the same way. We can describe this as relative motion between the conductor and field. But it's always important that the conductor cuts the field lines in some way. So why is this? Well, there will not be an induced potential difference when a conductor moves parallel to a field. Remember that between the two poles there will be a field represented by these field lines. If we move the conductor parallel to these, then it will never cut across any of them. So there is no induced potential difference. This is a very important fact that you need to be able to remember. Now there's one more way we can induce a potential difference, one that doesn't involve any motion. A potential difference will also be induced when there is a change in the magnetic field. So this way of inducing a potential difference is less common, but it's still something you could be asked about in your exam. So let's suppose we keep both the magnets and the conductor still, but then the poles suddenly switch around. This means the direction of the field the conductor is in reverses. This will also induce a potential difference in the conductor, as we can think of this as a type of motion between the field and the conductor. It's not just changing the direction of the field that causes this. Sudden changes in the flux density of the field would also induce a potential difference.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!